Hello friends, today I am going to talk about the iron-carbon phase diagram in this video. So you can see this one is the iron-carbon phase diagram. It is also called as iron cementite phase diagram. And this is called a phase diagram because it shows various stable phases of iron with respect to the carbon percent and temperature. So in this diagram you can see that as the carbon percent is changing, we are getting various different types of stable phases with as the temperature is being changed. So till 2.14% it is called steel, and above that it is called cast iron. There are various types of invariant reaction inside this phase diagram which we will talk about in later part of this video, and various phases present which I am going to say what are they. So first of all the phase is gamma austenite, which is FCC in crystal structure, which is phase centered cubic. Maximum carbon which can dissolve in this phase is 2% at around 1130 degrees centigrade, or in this figure it is can be seen that at around 1147 degrees centigrade. So this is the maximum percent of carbon which can dissolve in this phase. So the next phase is alpha ferrite, which is body centered cubic BCC. It is stable at temperature below 912 degrees centigrade. Means here this is alpha ferrite, and maximum carbon which can dissolve here is around 0.022, or it can go to 0.025%, and it is also 723 degrees centigrade, or in this figure you can see at 727 degrees centigrade, and 0.022% carbon the alpha ferrite can exist. Another phase is the lamellar mixture of ferrite and austenite, ferrite and cementite, sorry. This is a eutectoid mixture at around 0.8% carbon and 723 degrees centigrade. So in this figure you can see that here this one is the eutectoid point, and below this perlite exists as the lamellar mixture of ferrite and cementite. Another phase which is it is cementite. It is orthorhombic in crystal structure, and it is the hardest phase present in this phase diagram. It is having carbon around 6.67%. Another is the ledeburite, which is the mixture of austenite and cementite, and it happens to be present below this line 1147 degrees centigrade line here. Ledeburite, the mixture of austenite and cementite. So maximum carbon which can be present is 4.3% at 1130 degrees centigrade or 1147 degrees centigrade. So here you get a ledeburite mixture. Another is the delta ferrite, which is body centered cubic structure, and it exists from 1394 degrees centigrade to 1538 degrees centigrade. Till 0.10% of carbon it exists as delta ferrite. Till 0.818% carbon it exists along with austenite here in this inside this curve, and till 0.5% it can exist with liquid phase, which is till here you can see. So these are the various phases present in this phase diagram. So now as the temperature changes, the stable phases also changes. So until 0.22% of carbon, and here and 727 degrees centigrade, alpha is existing as independent. After that it exists along with cementite. Then above 727 degrees centigrade, and with respect to this line, austenite exists till 2.14% of carbon, or above 912 degrees centigrade this side austenite exists, and above 727 degrees centigrade austenite exists. After that it exists as with along with the liquid phase. So here we can see this is the solvus line. As we can see, the solubility of alpha is changing along with temperature, and this one is the solidus line, because below this the complete iron exists as complete solid form, and above this it starts liquefying, and this is the liquidus line, because above this line the iron is existing as complete liquid form. So various variant reactions are present in this diagram. Variant reaction is one whose degree of freedom is 0. So first one is the peritectic, where one solid and a liquid combines to form another solid. So this is happening at around 1493 degrees centigrade in this side. So delta along with delta FCF, delta iron combines with the liquid phase and it gives austenite. Another is the eutectoid phase at 723 degrees centigrade or the 727 degrees centigrade here. Here austenite, one solid breaks into two different solids. So here austenite is breaking into ferrite and cementite. The another is third one is the eutectic variant reaction. Sorry, this is the invariant reaction. Eutectic at around 1147 degrees centigrade. These invariant reactions these are the invariant reaction, not variant reaction, sorry. Liquid breaks into austenite and cementite, means here. So this is the phase diagram. As we can see here, the magnetism also changes along with temperature. The till 770 degrees centigrade, alpha iron exists in the form of BCC, and it is magnetic in nature, that is ferromagnetic. Above 770 degrees centigrade, it changes to non-magnetic or the paramagnetic, the same alpha BCC. And the temperature where this magnetism changes from ferromagnetic to paramagnetic, it is known as Curie temperature. So this one is the magnetism graph, which phase is magnetic and which one is non-magnetic. Then now austenite is non-magnetic in nature. Here one note is there, that is below 2% carbon it is called steel, and above 2% of carbon it is called cast iron. So in a nutshell, we can say the various phases and its crystal structure and along with features in this chart as I have drawn. Ferrite is BCC in form, it is soft, ductile and magnetic. Austenite, it is a face-centered cubic structure, it is soft and non-magnetic, and moderate strength is there in this phase. The another third one is the most important phase, is Fe3C cementite. It is orthorhombic in crystal structure and it is very hard and brittle. Now, in this figure we can see the eutectic point is this one, peritectic is this one, and eutectoid is this one. And below 4.30, the eutectic point, it is called hypoeutectic, and above 4.30 it is called hypereutectic. Similarly, below 0.77 or 0.8 it is called hypoeutectoid, and it is above 0.8 it is called hypereutectoid. This is a phase diagram in a nutshell. This can be used in various examinations to explain the iron carbon phase diagram. You can speak about the various phases present, the figure, this phase diagram. You can draw the change in the magnetism, the various invariant reactions present in the phase diagram, and in a nutshell the features of this phase diagram. Thank you.